The last video we saw how the, when resistors are connected in series, the current flowing through the circuit is constant. In this video we're going to explore what happens to the voltage in such a situation. Yeah, does it also drop equally across all resistances, or does it drop? Is there a greater drop across greater resistance? Now let's begin. So this, we're going to use this multimeter as our voltmeter. I've set it to 2. It's approximately 2. Let's begin by measuring the circuit voltage. Yeah. So what I'm going to do is I'm going to place these there and I'm going to switch it on. I think you can see it's about 2.55 volts. Now what I'm going to do is I'm going to begin measuring the voltage from here. You can see tracing conventional current through this up to the rheostat. Now, even though these are supposed to have very small resistances, they still have some amount of resistance. So let us, why not measure these as well. So what I'm going to do is I'm going to switch it on and measure it there. I don't know if you can see, that's 0.16 volts. So 0.16 joules per coulomb have been lost between here and here. 0.16 joules of energy have been lost between here and here. Next I'm going to measure the potential drop from there. What is the drop in potential from here across this and across our first resistor? So I'm going to switch it on, and you can see there's a potential drop of 1.12 volts. So 1.12 joules per coulomb are being lost between here and here. Primarily they are being lost as heat at our resistor here, and as small amounts of heat in the resistance in these wires and in the ampere meter. Let's move on. Now let us check the drop in potential drop between here, from this point flowing through here across this resistor to here. So essentially this ammeter, these two wires, this ammeter and this resistor, I'm going to switch it on. That is 0.84 volts. That means 0.84 joules per coulomb of charge flowing are lost between here and here. You can say lost or used, right? Lost if we don't want that to be there, but very often we want to convert the electrical energy to work, so in which case we would say it is being used. Now again, what we're going to do is we're going to check the potential drop between this point where we were last, across this ampere meter, across this resistor and back across this wire right till over here. So let's do that. And that is 0.44 volts. Now it's quite clear from this that the greatest potential drop was between here and here. The next greatest, that's 3 ohm, that's across the 3 ohm resistor. The next greatest was across from here to here, which is the 2 ohm resistor, and the next greatest from here to there, which is the 1 ohm resistor. So it is clear that in series, the higher the resistance, the greater is the potential drop. One interesting thing for you to do would be to take all the potential drops and total them and see, because remember the potential difference between these 2 points was 2.54 volts. That means there was 2.54 joules of energy per coulomb, that much of a difference between these 2 points. Why don't you total these and find out?